Right, hello there folks. So this afternoon we're going to be having a look at index law, otherwise known as having maths fun with powers. So there's going to be a load of this. Just to get us started, going to hark back to last week, which connects in with it, and I'm going to ask you for a starter to express 128 as a product of its prime factors. Pause the video and have a go. If you're thinking, what are you asking me to do there? If I just do this, now pause the video and keep on going. Hopefully you should remember now. Okay, so from that we've got 2 times 32, 2 times 16. Why am I circling the 2's? Because 2 is a prime number, the only even prime number, of course. 2 and 4, and then at the end we've got 2 2's, and what that means we've got is 1 2 3 4 5 6 7. So we could say 128 equals 2 times 2 times 2 times 2 times 2 times 2. I'm going to run out of space here, aren't I? No, I've just got room. Times 2, or 128 equals 2 to the power of 7, which brings us on nicely towards our first rule. And our first rule is so if I multiply a number to a certain power by the same number to another power, you add the powers. Why does that work? Well, if you look at this, you could say that that there would be 2 to the power of 4, that there is 2 to the power of 3, and if I do 2 to the power of 4 times 2 to the power of 3, what am I getting? Because I've got 7 2's lined up, I'm getting 2 to the power of 7. So that's your first law. Your second law that sort of goes with it is if you've got a to the power m and you divide it by a to the power n, because division is the opposite of multiplication, you end up taking the powers. Now that might be written as a division, it might be written as a fraction, in which case you might get something like this. Express this as a power of 5 to the power 8 over 5 to the power 2. Pause the video and write down what you think you should have for that. And it is 5 to the power 6, because 8 take 2 gives us 6. Next up, what do you think would happen if I had 5 to the power of 2 in a bracket to the power of 3? Well, because that literally means that times itself, so we've got 3 lots of it timesing by itself. That would be 2 plus 2 plus 2 is 5 to the power 6, which is 3 2's. So when you've got a bracket, we can say a to the power m with an n, that's going to be equal to a to the power m times n, which I could just write as mn, couldn't I? Now we've got a few other things we need to know before you can just practice it. First of all, anything to the power of 1, that's just the same thing as saying a number. So if I asked you what is 6 to the power of 1, it would be 6. We just don't normally bother writing the 1 there. Anything to the power of 0 though, what does that equal? You may remember this. It's actually 1. Why is it 1? Well, it comes about because remember when we had the division one, so maybe I had 7 to the power of 3 divided by 7 to the power of 3. That would be 7 to the power of 3 take 3 is equal to 0. And what is 7 to the power of 3? Well, it's 349 times 7, 343. So that would mean 343 divided by 343, and if you divide any number by itself you always get 1. So because this is why you get a power 0, you only get it when you've divided a certain number of power by the same thing, so it's always equal to 1. Quite often comes up as a 1 mark question, that. Now what happens if I had, for example, 2 to the power 4 divided by 2 to the power 5? According to index law, that would give us 2 to the power negative 1. Well, what is 2 to the power 4? 16. So I could say that that is 16, and I'm dividing it by 16 times 2 would be 2 to the power 5, which would be 32. Now if I simplify that, 16 goes into 16 once and into 32 twice, I've actually got 1 over 2. So 2 to the power negative 1 is 1 over 2. What would happen if it was 2 to the power 3 divided by 2 to the power 5? Well, 2 to the power 3 is 8, 2 to the power 5 is still 32. If I were to simplify that, I would get 1 over 4. And 1 over 4 is 2 squared. So, and that is 2 to the minus 2. And what that tells us is, if I've got a negative a to the negative something, a to the negative n, that's always going to be the same as 1 divided by that number to the positive. So you just park it underneath 1 on a fraction and turn the power positive. And once you've done that, you can find out what the value of the whole thing is. Okay, so pause the video and have a go at these 6. Right, pause it now. Okay, so the first one, 8 plus 3 gives us the 11 on x to the power 11. I didn't really give you an example to show this, did I? I gave you one that looked a bit like it, which is just 5 squared to the power. But this is 5y, which means we've got to do 5y times 5y times 5y, which gives us y times y times y is y cubed. 5 cubed is 125. So that's what you should have on that one. If you take the 4 from the 7, when you're dividing, you get w to the power 3. So here, all of this needs to be cubed, so I need to do 4 cubed. 4 cubed is 4 times 4 is 16 times 4 is 64. B squared to the power 3 is going to be 2 3s are 6, and then the c will be to the power 3. The fifth one, we are going to have to do 5 divided by 3, which you can just write as 5/3 to be honest. And then m squared divided by m is m, and n to the power 3 divided by n to the power 4 is n to the minus 1. There is an alternative way of writing this. You could say that it is 5m over 3m. So if you did that, that would be okay as well. And the last one here, 12 divided by 4 is 3, a squared divided by a is a, and c to the power 3 divided by c is c squared. Alright, now have a go at these. Evaluate means you've got to work out exactly how much it's worth, and your answer might either be a whole number or it might be a fraction. Okay, pause the video, give it a go. So anything to the power 0, remember, is 1. 2 to the negative 3, when you've got something which is to a negative power, you do 1 divided by, and it'll be that to the positive power, but that's not your final answer, because 2 to the power 3, 2 times 2 times 2 is 8, so this is 1/8. 5 squared times 2 to the power 3, well first of all, 5 times 5 is 25. times 2 times 2 times 2 we've just done is 8. So we've got to do 25 times 8. Well, 4 25s are 100, so 8 25s will be 200. 5 to the negative 2, turn it to 1 over the positive power. 5 squared is 25, so it's 1 over 25. And finally, we've got 2 to the power 3 squared, so that means 2 to the power 5. So 2 is 2. 2 squared is 4 times 2 is 8, so that's 3, 4. So 2 to the power 5 is 32. Okay, right, we're going to move on now to fractional and negative powers. Right, so you might be thinking, why do we need fractional powers? Well, they come about because of this. I put a box there to think, what number would go there and there so that this made sense? When we multiply, we add the powers, don't we? So if I had the same thing and I times it by itself, what plus itself would make 1? Well, that's going to be a half. So 9 to the power a half times 9 to the power a half equals 9 to the power 1, or just 9 as we would normally call it. So this 9 to the power a half must be the number which, when you times it by itself, you get 9. Well, we normally call that the square root of 9. The square root of 9 times the square root of 9 is 9, isn't it? Which would obviously be 3 in this case. But for that reason, we can say as a little rule that a power of a half of something is the same as the square root of it. And that's very important. And it would be lovely if that's all we had. I mean, we also have the idea that if you had a cube root of something, like 8 is 2 cubed, isn't it? So if I said 8 to the power of 1/3, that means the cube root of 8. So that would be 2, because 2 times 2 times 2 equals 8. But do we have to have a numerator of 1? And no, we don't. You're probably going to not be happy about that, but you will be very happy about it once you see how it goes. So if I had 8 to the power 2/3, I've got the top bit is powering up and this bit is powering down. So this is a power and this is a root. And you can do it either way. You could square 8 to make it 64. And then you could do the cube root of that to get back down to 4. But that tends to make life difficult because it makes the numbers bigger. So I would always say you want to deal with the root first. So I could say that the cube root of 8 will then need to be squared. So you work out the cube root of 8, which we know is 2. We square that, and it gives us 4. And you might think that was enough of all that, but what would you do if I said, well, what is 8 to the negative 2/3? And you're going to say, what the flip? Why do we need that? Well, we need it because we can do it. And anything which we can logically do will have a use somewhere. So the same as with a normal negative power is going to be 1 divided by this whole thing as a positive power. So the first thing to do, and you get a mark for doing this, is just to write 1 divided by it as a positive power. Then we think we go through this same procedure here. So I would then say, right, that's going to be 1 divided by, I'm going to do the cube root of 8, and then I'm going to square it. And at first, I don't worry about what that might be. I just write it down, go through the process. Then I look at it and say, oh, the cube root of 8 is 2, and then I square it. So the answer to that is 1/4. Right, so I'm going to give you some of these to practice as your final bit of a grade 6 practice, but it's as tricky as grade 6 ever gets, I think. If you're mastering this, you're probably going to be looking at a bigger grade than that, to be honest, but not to say you can't master it even if you haven't got up to that grade quite yet. So here's your first 6. Write them down, take your time, pause the video, have a go. The 5th one I haven't quite explained, so have a guess. Right, so power of a half means a square root, so it'll be the square root of 100, which is 10. Square root of 49, which is 7. Then a negative power, 1 over, and it'll be the positive power. I'm going to say that is going to be the square root of that straight away. So square root of 36 is 6, so it's 1 over 6. 64 to the third, that is cube root. So 4 times 4 times 4 is 64, so for that reason that is a 4. Now, when it's to the negative 1, you turn it upside down. It's called the reciprocal, actually, whenever you turn a fraction upside down. So this becomes 5 over 4, all to the power of 1, which means 5 to the power 1 and 4 to the power 1. So it is just 5 quarters, or 1 1/4, but you don't have to put it into a mixed number. They don't expect to see that. So here we've got a complex fraction, one with a numerator other than 1. So that means we're going to have the cube root of 125, and whatever that is, squared. Cube root of 125 is 5, so we're looking at 5 squared, which is 25. Good work. Okay, last few coming up. Okay, so here's your last 6 questions. Pause it, have a go. There's one of them where you won't get an exact value. You will still have x involved in that. Okay, so pause it and then see how you get on. Right, so first up, 1 over and turn the power positive. That's all you've got to do at the beginning. Then we're going to do a cube root of 64 and then square it. So the cube root of 64 is 4, so it's 1 over 4 squared. 4 squared is 16. X to the power of 0. You might not know what x is, but it doesn't matter because anything to the power of 0 is 1. 27 to the negative 2 over 3, so it's 1 over 27 to the 2/3. So that's 1 over cube root of 27 all squared. So that is 1 over cube root of 27 is 3. 3 squared is 9, so it's 1/9. This time, when we've got two numbers on top of each other, two different numbers, we do the reciprocal. So that is 16 over 25, and then turn it to a positive. Keep it the same though. Don't flip that one as well. I know that is confusing till you get used to it. But one way you can check is that you know you've done it right. They wouldn't ask you for a cube root of numbers which aren't cubes. They're square numbers, aren't they? So we want root 16 to the power of 3, and we want root 25 to the power of 3. Root 16 is 4, so we want 4 cubed. Root 25 is 5, so we want 5 cubed. So that gives us 4 cubed is 64, over 5 cubed is 125. And you may think a lot of these numbers are starting to look familiar, and that's because there's only a few of these that they can ask. I'm going to nip down and do number 12 before I do 11, because look at that. Those numbers are the same, aren't they? Turn that over the other way up, 125 to 64, and turn it positive. And it's cube root and then squared this time. Cube root and then squared. And we're actually asking for the same thing, aren't we? We're asking for 5 squared there. We're asking for 4 squared there. So that gives us 25 on the top and 16 underneath. And you can see that we've ended up where we started, only upside down because of these powers being the other way up. Okay, so we've got one left to go. 8x to the power 6. Now when you've got a coefficient of your letters, we've got to do the power 2/3 to the 8 and to the x's. So to the 8, that's going to be cube root of 8 and then squared, and then we're going to be timesing that by, well, when you've just got letters, all you have to do is times the what they call times the powers together, don't you? So that's going to be times x to the power of 6 times 2 over 3. So 6 times 2 is 12 over 3, isn't it? Now the cube root of 8 is 2, 2 squared is 4, and then looking at these x's, 12 divided by 3 is 4, so it's 4x to the power 4. And that's all your power fun done for today, I'm afraid, folks. So until next time, goodbye.